Hi everyone, welcome back to Learn with Pooja. So in previous video we discussed about a cosine similarity, Euclidean distance and Manhattan distance and comparison, and we have seen like one of the practical example with the cosine similarity. Now we are going to discuss about visualizing semantic relationship between text chunks using dimensional reduction techniques. So you can see the example workflow. It is like a text chunks. Roses are red. I love chocolates. So it is converting into the embeddings, creating embeddings. So n-dimensional embeddings and dimensionality reduction. So reduce the dimensionality by using PCA, and this is like a different part. So how it will work, we can go one by one. So we can discuss the practical example later. So first we can discuss the theoretical part. So dimensionality reduction for embedding visualization. Embedding vectors often contain hundreds or thousands of dimensions. For example, 1536, something like that. Visualizing such high dimensional data directly is not possible. So we use a dimensionality reduction technique to project these vectors into the lower dimension space, typically to 2D or 3D. The goal is to preserve the relative distance between points so that text chunks that are semantically similar in the original high dimension space remaining close together after projection. So you can see here one of the main technique we are using, principal component analysis. So principal component analysis is a commonly used the dimensionality reduction method. PCA work by identifying the directions in the data with the maximized variance and creating new axis called principal components. And third one is a projecting the high dimension vector onto these new axis. So when reducing, for example, 1536 dimension to 2, PCA keeps the two directions that capture the most information about the data distribution. As a result, you can see that text chunks with a similar meaning often remaining close together. Unrelated content tends to appear far apart. So here you can see that embeddings and the dimensionality reduction, PCS scatter plot. So you can see these are like rose are red, violets are blue, and I love chocolate. Ice cream is a delicious. This is like additions more, and the sky is blue. The sun is shining. So this is like a principal component. The data is will create like this. The visualization form. So, why visualization is useful during development? Embedding visualization is extremely useful when building and validating RAG system. During development, plotting embeddings can help verify that the semantically similar documents cluster together or different topics from separate clusters. Example, legal documents may cluster together. Marketing material may from another cluster. Technical documents may appear in the separate region. This confirms that the embeddings model is capturing meaningful semantic relationship. Visualization is also useful when presenting system to stakeholders or regulators, especially in the industry like finance, healthcare, legal hair, technologies. So showing clustering behavior makes the retrieval logic more transparent and understandable during demos. Limitations of 2D visualization. 2D plot should not be used in production diagnosis. Reducing 1536 dimensions to just two inevitable losses a large amount of information. Because of this, some relationships between vectors cannot be shown. So clusters may appear closer or farther apart than they actually are. important high dimensional structure may disappear. So instead, a production system should be evaluated using retrieval performer matrices such as precision, recall, and reciprocal rank or hit rate. These matrices measure how well the system retrieves and relevant documents for user queries. So trade-off between PCA, T-sign and UMAP. So several dimensionality reduction techniques are available, each with a different strength. So the method is like a PCA, fast and deterministic, easy to compute, may miss non-linear relationship. T-sign is a preserves local cluster very well and slow for large data sets and sensitive parameters. UMAP is like a preserves both local and global structure required parameters during. So PCI is like a linear dimensional reduction, very fast and stable, good for initial exploration. T-sign is like excellent for visualizing cluster, capturing local relationship, and computationally expensive. UMAP is like a often better than T-sign for large data sets, preserves both local and global structure. So faster than T-sign in many cases. So what are the key takeaway from this session? Dimensionality reduction helps us visualize and understand the embedding spaces during development. However, use PCA or a T-sign for exploration or and debugging. Use retrieval evaluation metrics in production. Visualization helps ensure that the embedding model is learning meaningful semantic relationship, which is critical for building effective rack system. So dimensionality reduction for embedding visualization. So embedding models often produce high dimensional vector. We discussed already, this is like a repetition. So now we can go with the documentation and also code. So we can discuss practical I mean to say Python code in the next video. So we can close that now, and yeah, keep following it, which is like a very most important information which I am sharing. So and please subscribe my channel. You will get more updated videos in this course. Thank you. Have a nice day.